Why the UK profile dominates UK specifications? The 60 profile is the most widely specified composite floor deck in the UK, and that's not by accident. Across the market it appears under different names: ComFlor 60, MetFloor 60, Firth TR60. It consistently delivers the lowest cost per square metre while still meeting the vast majority of commercial, residential, mixed-use building requirements. One of the most important things to understand about the 60 profile is that it can be used as permanent formwork. In simple terms, this means the steel deck replaces traditional timber formwork, stays in place for the life of the building, and supports the wet concrete during construction, taking weights of 1.5 kilonewtons per square metre, bare steel. At this stage, the slab is designed independently of the steel deck. The deck's job is purely to act as a safe working platform in shuttering while the concrete is poured and cured. The deck acts as a mechanical key within the slab, and it enhances the structural integrity and increases the acoustic value, thermal and fire resistance, while offering itself as support for ceiling hangers and M&E. It removes the need for temporary formwork and backpropping and unnecessary mess. It speeds up program, it allows other trades to work below much earlier. Once the concrete is cured, the deck has already done its job, and anything beyond that is a bonus. The true advantages of using any of our profiles comes when you design a steel frame compositely. Shear studs are installed, the system moves from a permanent formwork to a composite floor. At this point, the concrete slab and the steel beam work together structurally. The slab acts as the compression flange and the steel beam becomes more efficient in tension. This is why composite construction can reduce beam sizes and overall steel tonnage. But it's important to understand that composite action is optional, it's not automatic, and the 60 profile works perfectly well in both scenarios. Span capabilities without over-engineering typically unpropped spans of between 3.5 and 4.5 metres, a routine with 60 profile, depending on the gauge and the slab depth of course. With temporary propping, spans can reach just over 5 metres. That means fewer beams, fewer props, quicker access for follow-on trades. For most UK buildings, this is exactly where the efficiency curve peaks, which is why engineers stop at 60 before jumping into an 80 profile. I want to clear up a common myth while we're on the subject. Where composite action is required, shear studs are welded through deck to the beam. For stud welding to be carried out correctly, the top flange of the steel beam must be free from paint or coatings. This includes especially zinc-rich paints, which contaminates the weld. It compromises the quality of that weld. This often raises concerns, but it shouldn't. The galvanised steel deck itself protects the beam during construction, and once the concrete is poured and the deck and the slab together form a fire-rated encasement to the top flange. There is no fire vulnerability created by leaving the beam, the top flange, unpainted in these zones. In fact, the completed composite slab typically provides 60 minutes fire resistance as standard, 90 to 120 minutes with appropriate slab depths, and in some engineered solutions up to 4 hours fire performance can be achieved. The fire protection comes from the concrete mass and the steel deck, not from the paint on the top flange of the beam. Modern 60 profiles are deliberately detailed to reduce site risk. Trough stiffeners and side laps allow central shear stud placement. Stud welding is quicker and more reliable. Composite action is consistent and predictable. Less checking, less rework, fewer problems. Service integrations is built in. The profile shape allows easy fixings of hangers, clear routing of M&E services, straightforward ceiling suspension. That simplifies coordination later in the program and avoids unnecessary clashes. The commercial reality, cost per square metre wins. Put simply, The 51 and 54 or 55 re-entrant profile are chosen for acoustic or soffit reasons, not economy. It's the most expensive of the common shallow slab profiles used in the UK. The 80 profile offers longer spans. It's a middle-of-the-road cost per square metre, and it can be very efficient in scenarios where long spans are required. 60 profiles deliver the best balance of span, slab depth, fire performance and speed at the lowest square metre rates out of the 3 common profiles available in the UK. To give you an idea, typically for 1,000 square metres of the 60 profile, as I stand here in February 2026, you'd be paying around £20 a square metre on average for 1,000 square metres using the 60 profile. Plus, for the mesh and the concrete, inclusive of the pump, labour and prelims, you'd pay £45 to £50 per square metre. You'd save on programme, time, and coordination is much easier. To me it's a no-brainer, but hey, I'm biased.